So here in the process, what is the pressure is maintained 30 kilopascal and V2 minus V1. V2 is the final one, V1 is the initial one. V2, what we are taking 25 centimeter cube and V1 10 centimeter cube. So V2 minus V1 we are taken as one is 25 minus 10 into centimeter cube and pressure what we are telling as 30 kilopascal. See here if you are taking kilo means 10 to the cube and this one is 10 into 10 to the power of minus 2 whole cube minus 6. So finally what you are getting 300 into 10 to the power of minus 3, 0.3 here, 300 to 10 to the power of minus 3 here. This is about 0.3 joules. Next another process, if you are taking the second process, AD process, AD to DB process. AD here what happens, the pressure remains constant. So AD we can call as an isobaric process. AD is the isobaric process and DB is a again what happens that isochoric process. So we have to find out the work done during that second ADB process. First you have to find out work done along the AD and work done along what happens at DB. So work done along the AD process, here isobaric, here the pressure remains constant. So here work done is 10 into, so 25 minus 10 into centimeter cube, you have to change about this 10 into 25 minus 10, 10 into 10 to the power of minus 3 here, this is 100 into 10 to the power of minus 3. This is about work done along the AD. Whereas work done along the DB is a isochoric process. Isochoric process we know this, its value will be 0. Next another process, AB process. See AB here, how can we define this work done along this during this AB process here? The area occupied this AB graph with volume graph. See here, if you are taking this AB graph, volume occupied by this up to ADB, it's a triangle, and one more, this one I am representing by this particular rectangular D2 25 cc and 10 ccca. So total area will be during the third process. First one, work done during this AB process here. This is the third process. It's represented by 3 arrows in the middle of AD into DB plus again volume difference V1 minus V2 into the pressure value here 10 kilopascal P1. So here of AD means here 25 minus 10 and dB here what we are getting that, so 30 minus 10 kilopascal, and next what about this area here 15 into 10. So in this way we are going to find out the work done by the each process. See here for each thing, if you observe this A to C B one work done we are getting, ADB one work done we are getting, AB is also one work done. So here work done by the gas is a completely depends on the path, whereas du what happens that initial state is A and final state B, it depends only on initial and final. For all the three processes du has to be same, whereas dw has to be varied. So this is the example which explains there about that how the dw depends upon the path. Next, go to the next question. Here if you observe this one, 80 joules of the heat is absorbed by the system and 30 joule of work done is by it. If the system does 10 joule of work during the process ADC, how much heat flows into the during the process? So here this system is explained by the indicator diagram by taking the pressure and volume on that x and y axis respectively. See if you are taking this first process is ABC, this first arrow represents that ABC process. Here what happens that ABC process 80 joules of heat is absorbed by the system. In the case what happens that 30 joules of work done by each. See by application of the thermodynamics, first law of thermodynamics, dq is equal du plus dw. Here 80 joules is absorbed by the system. So once again we can recollect our assumptions. If the heat is absorbed by the system, then dq is equal to positive. So 80 joules, here heat is absorbed by the gas, so 80 joules we can take as a positive. Next du is not given. After that dw, what happens that work done by the gas, again work done by the gas is always positive. So here that dW is equal to 30. So du is equal 80 minus 30 joules. This will be 50 joules during the first process, that is called ABC. Next, second, if the system does 10 joules of work during the process ADC, here work done is given ADC process. So if you observe this, first process it starts from A, its process go through B and reaches the C, whereas second process it go from starting from the A and reaches the D and reaches the C here. See here, during this two processes, what we observe from this, initial and final positions are same, whereas path is different. That's what here the first process 30 joules of work done, whereas second process 10 joules of work done. Second process, if you are taking the second process ADC, dW is equal to, what is that, 10 joules. What is asking, how much heat flows to this one? So dQ is equal how much in during this ADC process, whereas in the first process dQ is 80 joules, dW is given. How can you calculate the du? Because du already is we are getting in the first process, the du only depends upon that initial and final position but not during the path. So in this process, ADC process also, du will be what we are taking in the first system, that is called 50 joules. So dQ is equal du plus dW. So this case 50 plus 10, this is called 60 joules. If you observe this first process, one is ABC process, one is ADC process, whereas dQ is 80 joules in the first process, whereas in this case 60 joules. Next, if you compare that work done, in the first process it's a 30 joules, here what should be the 10 joules. Both dQ are changing from the process to process, but whereas du will be same in both the process. So here du strictly it is a point function, it absolutely depends upon initial points and final points but not the path. Here 50 calorie of the heat should be supplied to the taker system. Already we discussed heat should be supplied to the system is a positive. 50 calories is given. Generally we are using the SI system as joules, so we have to convert the calorie into the joules now. Next, state A to the state B through the path ACB. This is the first arrow represents that ACB process, and find the quantity of heat to be supplied taking it from A to B via ADB here. Here initially what happens that heat is given from the process ACB. Next he is asking that what is the heat is to be supplied to the system for the process ADB. So first one, what you have to find out? First you have to find out that what is the work done along that ACB process. He is already is given dQ. So dQ is given, that is called 50 calorie. We can convert into joules 4.2. This is the joules. Next, after that you have to find out the work done. Just last problem we discussed how to find out the work done by this process ACB. If you observe that ACB here, AC process, what process here? Isobaric process. Here the pressure remains constant. Whereas BC process, volume remains constant. It's an isochoric process. So here during that ACB, what is the work done? It's the sum of the work done of AC process plus CB process. But isochoric process already we discussed that work done is a 0. Only the work done is carried out by process from A to C. So how can you find out pressure into V2 minus V1? So pressure here, what happens that 50 kilopascal here into V2 minus V1. This can be 400 minus 200 into centimeter cube here. So minus 2 meter whole cube. So this can be 50 into 10 cube into 200 into 10 to the power of minus 6 meter cube here. These are all the SI system. So here 50, here 2000, 50 into 2 here 100, and again 1000 this one into 10 to the power of minus 3. So finally what we are getting 10 joules. From this dQ we are getting 50 calorie, dW is given. So easily we can find out du by taking that dQ minus dW. So this process we are getting du. After that he is asking about the quantity heat to be supplied this. You have to find out the work done along the ADB process. Along the ADB process, what happens that, so AD process, it's an isochoric process. Here the volume 200 cc is maintained constant, and DB process, here the pressure, what happens that remains constant. You have to find out that work done that can be is equal 155 into the volume difference 400 into 200. This way you have to find out the work done. So already we are getting du, so du plus dw, that we are getting dq. Next question. If you observe the next question, heat absorbed by the system during the cyclic process. Here it is a system of process. Here the indicator diagram is presented by the pressure and volume, their parameter. So you have to take this, the area with volume axis. So here this is measure of circle here. So pi into, so what is the diameter here? So this one is 200 and this one is also 200. Anyway, circle will have same that. So pi into r1 square. So pi r square. So r you have to find out. This can be 100. So pi r square, that gives your heat absorbed by the system. Because it's cyclic process, du has to be 0. Only you have to find out the dw, that can be equal to dq. Next. After that, gas is taken through a cyclic process ABCA here. If the 2.4 calorie of the heat is given the process, what is the value of the J? This type of question generally they are asking the exams. If you observe this, it is a cyclic process. By taking the cyclic process, immediately you know this du has to be 0. First you have to find out what is the work done during the process. Just to check out, so is a process of AB here. AB process, it is completely what happens that isochoric process. So work done here, what happens that it's a 0. Here BC process and CA process. So directly what you are getting is like a triangle. The area with this of AB into AC, that you will get that particular area, that's a work done. dW is equal, AB is how much? So 200 minus 100, this can be 100 kilopascal into here volume difference. So 200 into 10 to the power of minus 6 here. So 10 to the power of 4 into 10 to the power of minus 3. So 10 joules we are getting dW. Here in this process, dq is equal du plus dw, whereas du is equal to 0. dw we are taken as 10 joules, but he is given as in terms of calories 2.4 calories. He is asking that J value of the J is equal this 10 by 2.4. This is your value in terms of joule per calorie.